Alright, good morning. Welcome to the last part of this chapter. And this part of the chapter, we'll be talking about the motor effect that we have learned previously, and in terms of how it can give us a turning effect, okay, that we can use in the motor itself. So let's take a look here. We have a rectangular coil of wire with a current passing through it. So imagine if the current were to pass this way, this direction, what will happen if it is placed in the magnetic field, north, south? That means that the magnetic field is in this direction. The current is in the coil that flows around it. It will have a force. So how will this do? Let's consider the wire, this segment of wire. Current goes here. Magnetic field goes here. Remember, this is 90 degrees. What will happen? BI go, it goes inwards. Okay, so this is a force. Takes a bit of imagination. So that's why it goes inwards. Let's take a look at the other side here. Now your current goes down. Magnetic field is still here in this direction. And BI goes down. See that this comes out. Okay, here. So what happens is one goes in, one side goes in, the other side comes out. There will be a turning effect and cause this to rotate. Okay, so this is what happens when you place a rectangular coil of wire into a magnetic field. Now you can increase this turning effect. You want it to increase as much as you can, but how can you do it? Increase the number of turns of the wire coil. So for this purple color thing, just make sure that you coil many times. Next, you can increase the current. So the current that's flowing through the whole coil itself, you can increase the current. It will increase the turning effect. What else can you do? You can increase the strength of the magnet by bringing the magnets closer. So you increase B also. Please take note also that when it rotates, we can bring in our principle of moments. This axis here is the pivot. Okay, so everything that measures in terms of the moments must measure from this line of action. Okay, so if the force is here, the distance must measure from here to here. Similarly for the other side. Okay, all right, the next part. Now, if we look at this itself, the problem here is that there is a rotation of 90 degrees. After that, this setup will stop. And the force will remain the same. There will be no other movement. It cannot turn one full 360. So there must be a modification of this design so that it's able to turn. So what is the modification? Let's take a look below. So how do we modify it? We have to modify by using a split ring commutator. Basically, it's just two pieces of metal. Instead of one full piece, now it's two pieces with a gap in between. Okay. What will happen in between is there will be carbon brushes, basically just to contact, to close it just like a wire. And yep, so that's the main difference itself. When we have this setup, we let the current flow, we produce a magnetic field, and there will be a force being generated. In this case, let's measure for AB. So AB, we're looking here at this segment here, AB. So the current goes in, magnetic field goes here, FBI, it goes down. And the other side, we're looking at CD here, current is here, magnetic field is here, FBI, it goes up. So let me clean this whole image up. This side goes down, this side goes up. So as you can see, it rotates this way. So it turns about this axis, which is the pivot, and it will continue. When this thing turns itself, this brush at first is touching, let's say I label this as 1 and label this as 2. At first it's touching at 1, it will pass through again, and then it will pass through 2. So what will happen is the current will then flip. So this part originally that was supposed to have the current coming out. After once this carbon brush reaches the other side of this split ring commutator, the current will change direction. And when the current change direction itself, there will be a different effect that causes it to continue to turn. Okay? All right. Now, this itself is what we call as a DC motor. Why? Because it uses a DC current, a direct current. It's not an alternating current, such a one current flow through is able to let this thing to keep turning. What is the purpose of the carbon brush then? The carbon brush is to ensure that it has a good contact with the split ring commutator. What's the purpose of split ring commutator? Its purpose is to be able to reverse the direction of the current in the coil every half a revolution whenever the commutator comes into contact with one brush to the other. So this ensures that the coil always turn in the same direction. So let's take a look. Why does the current have to change every 180 degrees rotation? That means halfway, why must it change? So let's use our FBI. B is in this direction. In this case, current is going in. Okay, FBI, so this is in. I'll just use the word in so it's easier to identify. In, FBI, I is in, B is there, so this thing goes down, force. This one itself, current is coming out FBI, current B is there, so this one goes up. So as you can see that this will cause a rotation. Now when it turn, now imagine the coil is like this. Okay. The top part here, we have a current here, FBI, so now it's coming out. It's going in. So FBI, I comes out and goes there, B goes there, force will goes here. So this is a force, and similarly for the side of force goes. So as you can see, this stretches the coil, but it has no effect in causing it to turn. So that's why you got to flip the current. Okay. Now, to increase the turning effect of the coil, what we can do is to insert a soft iron core cylinder into the coil to concentrate the magnetic field line. So you can insert a iron, okay, into the coil to concentrate the magnetic field lines that is passing through this coil. Okay, we can increase the number of turns at the same time. So there are a few things. Number one, you can insert a soft iron core or cylinder. You can also increase the number of turns in this coil, or you can increase the current in the coil. So there are three ways to actually increase the turning effects of the coil. Okay. Otherwise, I think we will end here. Thank you very much.